starten ไปไม่เอ่ยเยอะin YouTube email go to your channel go live open widget yeah yes oh immediately Untitled Chapter Untitled Chapter SCI33205 M605 is 0.8.2021 yes that's it open widget close it rightครับเนี่ยcome on right here close it so petty I tried last thing maybe this one and yes this oh not sure it's going to be this one right ครับthis is welcome you to good morning everybody welcome you to SCI33205 right and ปกติที่605จะไม่ค่อยมีคนไปที่ YouTube ใช่ไหมเนี่ยถือว่าก็ส่งให้แล้วกันเนาะเป็นตามนะครับที่รุดนี่คือไม่เรียนแล้วใช่ไหมครับหรือว่าไงคือขาดการติดต่อห่างหายไปเนิ่นนานมากครับอะไรนะผมต้องหาอันนี้สักนิดใช่ไหมyes M605 this one and another link is this oneลืมแชร์หน้าจอyes Tragung starten alright yes yeah in นะครับส่งลิงก์ให้ไปแล้วครับก็จะประมาณนี้ yeah anything else nothing more right and let's me check whether the voice the audio works perfectly or not all rightที่ซูมเสียงได้ยินไหมครับwhat happened โอ้ไม่ต้องรูฟครับกิตภพเข้ามาที่316ครับกิตภพเข้ามาที่อันนี้คือที่ซูมใช่ไหมเดี๋ยวนะไม่ได้โทรกลุ่มนะครับ2601and let me get into theเพราะว่าเดี๋ยวโทรกลุ่มแล้วเดี๋ยวมีคนหลงไปนะครับผมก็เลย316ธรรมดาเลยแล้วกันนะครับ alright ไม่มีใครใช้ที่ YouTube นะครับแต่ว่าก็สตรีมไว้ให้คุณเผื่อคุณจะใช้มีนะครับเข้ามานะครับ alright ต่อได้ครับมีคนอื่นอีกก็เสียงใช้ได้นะครับทั้ง2ที่นะครับก็มีพิมพ์ชื่อมาแล้วนะครับก็คือณัฐวินใช่ไหมคนแรกคือณัฐวินใช่ไหมครับเดี๋ยวผมกลัวกดอัดไปแล้วเดี๋ยวหาไม่เจอยากอีกนะครับคนแรกณัฐวินนะครับที่2ก็วิทย์นะครับ3ก็วชิรวิทย์6กิตภพนะครับ17พฤตินัม8พีรทัศน์8แล้วก็23ภาษิตนะครับคนอื่นก็เข้ามาทีหลังก็ได้ครับผมถอดหูฟังกันนะเสียงใช้ได้ทั้งคู่นะครับเพราะต้อง include ไฟล์ใหม่นะครับมันเป็นไฟล์ใหม่ที่เกิดขึ้นมีมาด้วยกิตติวัฒน์นะครับมี2คนนะครับปฏิหาร ปฏิหารพิมพ์ชื่อมานะครับถัดจากภาษิตก็มีวลินทรพิมพ์มาวาลินพิมพ์มานะครับปฏิหารพิมพ์มามีอะไรธนทรนะครับ มานะครับโอเคมากรก็พิมพ์มานะครับมีคนไหนอื่นอีกไหมครับ ก็ถ้ามีแล้วผมจะโหลดมีคนเข้ามาลงตะกอนนะครับกิติวัตรพิมพ์มาเพิ่มนะครับแล้วก็ปานทรครับพวัตรก่อนถ้าจากก่อนก็เป็นกิติวัตรนะครับกิติวัตรพิมพ์มากฎชวงวัตรนะครับกิติวัตรนนทกรเข้ามาใหม่ผมงงว่าทำไมต้องกดรับคุณด้วยตอนแรกๆแค่รหัสพาสเวิร์ดก็จบ alright มีใครไหมครับผมจะโหลดไฟล์แล้วนะโอเค alright yeah. That's the new portal this yeah พวัตนะครับนนทกรพิมพ์มาแล้วก็ชงวัดนนทกรพวัตนะครับพิมพ์มาเพิ่มนะครับที่ YouTube ไม่มีใครไปดูนะโอเคครับก็จะได้ไม่มีปัญหาก็จะสตรีมไม่ให้ครับเพราะว่า604เขาชอบอยู่ที่ YouTube กันครับโอเค alright welcome you to SCI33205 this is the section of the class for M605 from 10:10 to 11:50 and we're gonna leave the students 20 minutes before the end according to the policy of relaxation okay given by the school here we would start with the story the content of the direct current motor right and it's almost at the end of the chapter we have already passed or talked about the galvanometer right the galvanometer can be used as the ammeter right in order to measure the what is that the current and we can also use the galvanometer as the voltmeter right in order to measure the voltage and that's it if we once we have applied it okay all right and here okay we start with the direct current motor right and I guess that in M605 I have explained something already right yeah the direct current motor ผมกดอัดแชร์หน้าจอแล้วนะเดี๋ยวลืมนะครับเคยไหมเดี๋ยวเกิดการลืมได้ภาวัตเรียบร้อยนะครับโอเคนนทกรภาวัตนะครับ alright now let's go further with the direct current motor alright here the motor should have of course the frame right the body of the whole structure and it just stay constantly like this okay it doesn't rotate all right and yeah it is built up with this shape okay so that we will turn around the conductor at this side okay let's say it's the right side and here on the left side there is also a place like this okay in this area it's a little bit curvy okay it has a curve it's like part of the cylinder okay in order to support this one something inside and at this part we just hang the conductor. All right, and here is the cylinder, right? Cylinder in this way. And what else? The conductor just lay down, okay, in this way, and we let the electric current flow in to this conductor, the left side and on the right side. The reason behind that is the following: we want to generate the magnetic field, okay, from this one to this one. Okay, in this case, is this one is not south, it's N. Okay, it's not N, it's south. Okay, because the according to the beginning of this chapter, we have learned that the magnetic field lines start from the north pole to the south pole, right? And yeah, and you can see that here the magnetic field line will start from this side to this side, and yeah, it's going to turn around like this. And what else? Yeah, that's the static part. Okay, yeah, we call simply in electrical engineering, we call it as stator. stator ก็คือ static part นะครับเข้าใจไหมส่วนที่อยู่นิ่งๆนะครับ static component. Okay, and another part which is inside this the whole frame here is the cylinder. Okay, and the cylinder is connected to a smaller cylinder. Okay, here this part is called commutator, but the whole cylinder here is called rotor. Rotor comes from rotating part. All right, and that's the rotor. And what happens with the rotor is made in the shape of a cylinder, and it has a small it is dipped somehow here so that we get a slot. Okay, we get several slots and we lay down the conductor into this slot. The reason why we should have the slot and we lay down the conductor into the skin of the cylinder is because there is air right between there is air gap, and there is of course air between the rotor and the stator. Okay, both parts, the rotor and the stator, don't touch each other, and at the end of the rotor, okay, it will be connected to the bearing ลูกปืนครับโอเคไหม and the แต่ละลูกปืนครับโอเคไหมให้มันหมุนลื่นๆนะครับโอเคไหมand at the end of the rear part of this rotor is also connected to the bearing, so that the rotation is going to move quite freely. And what else? Yeah, we have several pairs of conductor, right? And here is okay. We have several pairs, and all the thing here can move. All right, and we connect the battery. Right here in it's any direct current power source. Okay, it has positive polarity, negative polarity, and it's connected like this. All right, and yeah, the black one represent the conductor. Okay, it just transfer the current, okay, from the source to this device. Okay, and this device is called brush. All right, so you may have heard it. It's brush. Okay, on this side, and it has somehow like this on another side, on the left side, like this. This is on the right side, and yeah, what else? The functionality of the brush is that it deliver the current from the conductor, the black one, to the conductor here, okay, which is laid down on the commutator, okay, and on the commutator, for example, you have one pair, two pair, right, and three pair, four pairs, okay. You have 8 lines of conductors along the in the slots of this rotation of this cylinder of this rotor, right? But there are only 4 pairs โอเคไหมครับปัตทัดเพิ่งพิมพ์ชื่อมานะครับ alright and what else the conductor the brush will deliver the current to this one because this conductor and this conductor on the commutator will further send the current and the current will flow in the rotor and the rotor will return, okay, along this line, okay, at the rear part of this rotor, and it just alive at this side and it go along the commutator, and the current of this conductor of this wire will be transferred to the brush, okay, and the brush will send the current back to the negative polarities of the battery, okay, and that's the whole process of current movement. But the important thing for us is that we have to, when we have just study the induced force, right, from this one, okay, this connector, okay, it's connected like this, okay. So you, because the current flows in this direction, we have vector L, okay, on the left side. This is vector L. Oh no, this is vector L, and of course, because of this coil, it's called field coil, okay, it's the coil that generate the magnetic field, okay. It doesn't move, it just stay constantly like this. And what else, because of this field coil, okay, it will generate the magnetic field in this direction, right? It's like the North Pole here, and you have the B vector, right? B vector in this string, and here is 90 degree, right? It's 90 degree, and of course, in order to determine the induced force, F equal I, right, and L cross B, right? You get the rotation from the vector L to vector B, right? And by using your right hand, you're gonna find that the induced force is going to point up or downward like this. It's F left, okay. Let's say it's the F on the left side, and let's take a look at the conductor on the right side when the conductor just is just laid in this way, okay. It's aligned horizontal like this, and yeah, because the current flow in this direction, the vector L like this, and the magnetic field B is gonna be somehow like this here. All right, and yeah, this is again the 90 degree, right, in the right angle, and we have to rotate from L to B, right? So L to B, from the green to this one, okay. I don't know the name of this color, and yeah, L to B, you will get by using your right hand, you will get the induced force along this line, right? The force is pointing downward like this, and here, yeah, that's what happened. Oh no, L to B is upward. I'm sorry for that. L to B, right? You will get upward direction. It's FR, right, on the right side. You get the lifting force on the right side. You get the down pushing force on the left side. So it's gonna be the couple force, okay. The couple force means the torque, okay. So it means this rotor is gonna move, okay, in the counterclockwise direction. All right, and that's the whole thing that happens, the whole mechanism that happens in this direct current motor. Okay, when this one move to this position and this one will move also to this position, this conductor will move to this, and this one is going to stay instead of the original one. Okay, so this is the pair conductors to each other. So the same process of force induced will happen. Okay, and that pair will cause the induced force, and this rotor will further rotate. Okay, when it turns around 360 degree, okay, the rotor will rotate easily, and that's it. Okay, and what else? Is there anything else? Nothing more. I think yes. This is the whole thing you have seen. Center pass of armature or the rotor is a cylinder or soft steel. Okay, it's made of soft steel. One thing is that the conductor should be submerged into a special liquid. Okay, and that liquid will serve as insulator. Okay, so that the current will not disperse into the, will not be sprayed, will not spread into the rotor. Okay, because this rotor is made of metal, so there should be insulator inside this, or even you use the normal copper wire. Okay, with the urethane cover. Okay, or the plastic cover. It's also usable. Okay, any kind of insulator, so that the current will not leak, to the rotor. And that's the whole thing. The ละวิพลครับละวิพลนี่มาช้าตลอดครับโอเคstationary graphite blocks are used as the brush. Okay, and brush just works as the device. Okay, that make the slightly contact with segmented cylinder, which is called commutator, right? In insulator are embedded into the slot, and the slot is in the rotor surface. Okay, it's parallel to the axis. In the coil F and F are called field coil. All right, here this coil and this coil are called field coil. All right, คุณก็จะงงนะทำไมเรียกขดลวดสนามนะจริงๆมันก็เป็นขดลวดสร้างสนามแม่เหล็กเหมือนกันมันก็สร้างสนามแม่เหล็กทั้งคู่ครับเพียงแต่ว่าอันนี้คือตั้งใจให้มันเป็นสนามที่เกิดขึ้นในมอเตอร์จริงๆเขาก็เลยเรียกฟิลคอยล์ส่วนอันนี้คือพวกที่หมุนเขาเรียกว่าพวกเก่งก้านะเก่งก้าก็คือเมเจอร์แก่ก้าอะไรอย่างเงี้ยโอเคไหมอยู่ตรงข้างในมีขดลวด2ชุดขดลวดอเมเจอร์กับขดลวดฟิลขดลวดสนาม alright and with that direction the rotor is gonna move or rotate, and it will produce the counterclockwise torque on the rotor. And what else? Here is another simple figure. Okay, that just shows only a single turn. Okay, single turn of the conductor. All right, and this one is quite simple for you. Okay, but it doesn't use anymore the commutator. It just uses the new thing, which is called split link. Okay, split link is a kind of commutator. Here you have, this is the link, right? It's like you go to Dunkin' Donuts shop, and that place is that piece is the donut, right? Then it's the split link is made of such kind of thing. Okay, first of all you have the donut side. This is called slip link. Okay, the slip link is not what we're gonna see in this subject. Slip link ภาษาไทยเรียกว่าแหวนลื่นแล้วกันนะแหวนลื่น Another one is the link, right? But you just cut it like this. All right, right here. Yeah, You just cut part of the slip link, okay, and this is called split link. Okay, split link is the broken version of the slip link. You can say that, but it's good. It's used to support the motor, the direct current motor that has only a single turn of the coil, okay, or a single pair of the coil. Okay, but if you have many pairs of the coil, you would rather use the commutator like this. All right, here is the split link, which is used for a single turn of the coil. All right, and that's it. Yeah, we have permanent magnet, okay, as the static part or the stator. Okay, we have north pole and south pole. Here is the permanent magnet, and we don't have the field coil. Okay, this is the simplest version of the motor. Here you have field coil, right? Another group of the conductors that is used to generate the magnetic field, and the magnetic field just stay constantly like this. But in this model, they don't use the field coil at all. Okay, we replace the field coil by using the permanent magnet. Okay, but it depends. Okay, the permanent magnet may work well, but it's a rare earth metal, right? Sometimes there is limitation of the amount of this metal in order to make the permanent magnet. In one way is that you just build up your field coil, okay, and the good thing from the field coil is that you can increase the strength of the magnetic field too, okay, by increasing the induced current, okay, according to the formula which is given by B. and Savard, right? B mu 0 I 2 pi d, right? And yeah, you can increase the magnetic field by increasing the amount of current, okay, this one in this is the field coil version of the direct current motor. But if you use the permanent magnet, you cannot control, okay, if you use the permanent magnet like the north pole and south pole, you cannot, I would say 100%, you can't completely control, you can't definitely control the strength of the magnetic field, okay, because it's fixed, okay, according to the type of the material you are using as the permanent magnet, okay. But in terms of field coil, okay, you can increase the magnetic field by using this formula, could be also. And yeah, that's the matter whether we use the permanent magnet or the field coil. There will be induced, there will be magnetic field pointing from the north pole to the south pole like this, okay, horizontally. And yeah, we connect the battery on the positive side to the connector, which is denoted by the black line here, okay. There are two black lines on the left side, which is given for the negative polarities of the battery. This is the positive polarity of the battery, and the current will flow from this one to the brush, okay, the first brush on the right, and the brush will deliver the current to the split link, okay, this piece of the ring, and the ring is connected to the connector, so the current will move to connector along this way, right? Here this direction, and here is the direction of current movement. Yeah, and the currents will go from this one, okay, to this bar, to another part, and to the split link on the another split link, okay, on another side, and the split link is connected to the brush, okay, another brush, and the brush is connected to the connector. The current will flow like this, okay, downward and right to the left polarity of the battery, and that's the whole thing, whole process of current flow in this motor. เดี๋ยวผมขออนุญาตเข้าห้องน้ำแป๊บนึงนะครับไม่ได้แวะเลยนะครับจาก004นะเพราะว่าอธิบายภาษาไทยให้เขานะ Okay, let's go further. It's good that you have got to know the model because this will serve as the background. จริงๆเรียนแค่นี้ก็ทำงานสร้างของอะไรได้แล้วครับรู้จักโครงสร้างเบื้องต้นของมอเตอร์นะครับโอเคไหมก็จริงๆมันก็สูงกว่านี้มันก็มีนะครับก็คือพวกเรื่องมอเตอร์แบบไฟฟ้ากระแสสลับครับซึ่งอันนั้นควบคุมความเร็วได้เลยนะด้วยความถี่ของกระแสไฟฟ้าสลับนะครับก็ซึ่งถูกใช้นะครับในยานยนต์ไฟฟ้าทุกวันนี้นะครับโอเคไหมซึ่งมาแรงมากกว่าเครื่องยนต์สันดาปคุณไม่ต้องไปเรียนพวกเทอร์โมไดนามิกในบทถัดไปนะบท3บท4นะครับบท4นะน่าจะเป็นบท4อ่ะไม่รู้ทันหรือเปล่านะครับไม่ต้องเรียนแล้วพอcombustion engine ไม่ใช้แล้วนะเครื่องยนต์สันดาปครับจะมาใช้มอเตอร์เนี่ยการทำงานนะครับยุคสมัยใหม่นะครับดังนั้นเป็นประโยชน์สำหรับคุณนะครับโอเคไหมเพราะผมอาจจะอยู่ไม่นานนะครับคุณยังอยู่อีกนะครับก็ yeah you got to know the idea of the direct current circuit right in like this all right yeah let's continue our story โอ้ลืมไมค์ของซูมนะครับไมค์ซูมoh I'm not sure what so right okay it's perfect okay here yeah we need to determine direction of the induced force right of course at this bar okay this bar this piece of the whole conductor you have the vector L on the right side right this is the right side of the conductor loop you have the vector L like this all right and because this is the north pole this is the south pole the magnetic field lines we start from the north pole to the south vertically horizontally like this is the vector B magnetic field and the angle between them is gonna be 90 degree, right? This one. Okay. L and B this way. ผมวาดยังไง ไม่ใช่ละ Okay, the magnetic field is gonna be somehow like this. Right? This is B. All right. And what else? Yeah, the angle between them is 90 degree, right? And according to the formula FILB, okay, it is still be induced FIL cross B, right? That's the induced version for the force on the long straight conductor. Yeah, we have to rotate from the first vector L to vector B, right? And you will find that the force is going to be downward force. Okay, that's the force on the right side. Okay, and that's the whole thing that happens. And here you have the force on the left side in this direction. And you have the magnetic. This is vector L. This is vector B, right? And L to B again. You get and you get the vector F in this direction, right? From L to B, right? We have to curl again our four fingers from L to B, the first vector, to the second vector, and that's it. Yeah, the rotation. Okay, from L to B, you get the pushing force. Okay, the downward force on the left side. Okay, on the left side you get pushing force. On the right side you. Oh no, L to B. No, I'm stupid. It's not downward force. It's upward force. All right. Yeah, it's the upward force. F left is gonna point upward like this. Okay, from L to B. That's right hand. Yeah. You can see that this is the lifting force. This is the downward force, right? And of course the rotor is gonna rotate like this. Okay, and that's the reason why we see the rotation direction or the rotation arrow from this one. Okay, and yeah, when this one move, this one will touch the current, and this will be in this angle, and there will be pushing force. Okay, in this one move to this one, and it will subject to upward force. Okay, the whole current will rotate. Okay, as soon as you have the current, okay, supplied to the split link, you will get the rotation. Okay, but there is limitation for the direct current motor that uses the split link commutator. The limitation is that once you let the motor rotates for a long time, because this is the rubbing area, right? It has a friction, and the thickness of this brush is gonna be thinner, right, until it disappears. Okay, because it rubs the split link every time, right? This piece will finally diminish. Okay, will vanish. So when you arrive at that situation, you could imagine, because the whole thing will be covered by some frame, right? You cannot see it by eyes, but they just take it out so that you can see all the mechanism that happens here, right? Well, at that time when your brush remains really tiny, with a tiny amount, almost vanish, you will get some sucker behavior of the motor. Okay, some sluggish rotate and not rotate sometimes of the motor, and it's the time for you, okay, to replace the brushes. And yeah, the good thing for such type of the motor is that it's quite simple. I'm not sure whether it's simple or not, but it seems to be simple. But the disadvantage or the shortcoming is that there is friction here. Okay, the purpose of any motor is that you want to get the torque as much as possible from the energy you have delivered to the motor, right? But here at this point, as you see, there is a rubbing area and there is friction. Okay, we didn't consider yet the friction in the bearing that hold the rotor to the frame of the motor, right? But that one is also a source of friction. But for the main part of the DC direct current motor itself, here is the first component, first point that generates the friction, and the friction is not good for any device because it will give you heat. Okay, we don't want the motor to have heat at all, right? It's gonna increase the temperature, working temperature of the whole motor. Is not good, and all the stuff here can be molten. Okay, it can get damaged. Okay, from the hot temperature, the high temperature, from the hot weather around here. And the second thing is that this is the friction, and the friction will reduce the torque and the force of the whole rotor here of this motor. Okay, you just lose some efficiency according to the touching process between the brush and the split link commutator. All right, yeah, it's not good. But anyway, it's the first type of the motor we can learn. Nowadays, I think when the time goes by, new technology has come. They may prefer something else. But this is the simplest device you can imagine from the theory of conductor loop. All right. Now, is there anything else? The one of the bad thing is that when you use the brush together with the split link, there will be dust. โอเคฝุ่นนะครับจะฟุ้งกระจายพอมันเสียดสีนะมันจะมีฝุ่นกระเด็นอยู่นะแล้วพอใช้ไปนานๆคุณจะไปเห็นว่าฝุ่นไปครอบอยู่ตามเส้นลวดอะไรเงี้ยมันก็จะไปบดบังเส้นแรงแม่เหล็กไปอีกครับก็จะมีความสิ่งที่ท้าทายอยู่โอเคไหมครับก็ไปออกแบบนะครับขึ้นกับบริษัทคุณอาจจะจบม.6 ไม่เรียนปริญญาตรีก็ได้นะออกแบบตั้งบริษัทสร้างมอเตอร์ขึ้นมาเลยก็ได้นะไม่จำเป็นไม่ต้องสนการศึกษาสมัยนี้เจ้าของ Microsoft เจ้าของบริษัทใหญ่ๆ Apple แล้วเขาก็ไม่ได้ต้องเรียนจบปริญญาตรีก็ได้นะครับขอแค่มีความรู้ซึ้งเรื่องใดเรื่องหนึ่งครับก็น่าจะเพียงพอแล้วนะครับแต่ถ้าอยากทำงานเงินเดือนก็เรียนครับมาเรียนแล้วเป็นเหมือนผมนะครับหลงระเริงจนถึงปริญญาเอกโอเคไหมครับถอนตัวกลับไปทำงานวิศวกรไม่ได้แล้วนะครับเสียดายสิ่งที่เรียนมาครับก็เลยต้องมาเป็นคนสอนหนังสือแทนอย่างเงี้ยนะครับโอเคไหมคุณเลือกเอาเลยครับแต่ในโลกความเป็นจริงนะครับสำหรับประเทศไทยนะงานวิศวกรรมไม่จำเป็นต้องเรียนสูงมากนะเพราะว่าเราซื้อของมาใช้นะครับไม่ได้ออกแบบดีไซน์เองก็มีเหมือนกันบริษัทที่ออกแบบเองครับก็ใช้ความรู้ที่เรียนไปพอสมควรนะครับโอเคไหมOkay, let's get back to our story. We have finished the explanation of the simple case of the simplest case of the direct current motor, right? And yeah, everything has been explained. Graphite is a good electrical conductor. It's a good lubricant. Okay, they use graphite because it seems to have the least friction. All right. You can use any material. Maybe in nature there is zero friction, and that will be great. Okay, for the human. Yeah, the whole thing here is what I just explained it. I just listen and explain. Here is another type of the motor. It has the first pair. Okay, 1 and 1 prime. Okay, this is the connector that is connected. This is the rotor, right? The rotor. We don't pay attention to the stator at all. Okay, we just simply take a look at the magnetic field. Magnetic field start from the right to the left. Okay, it's pointing. It points to the left like this. Okay, and there are several lines. Okay, and yeah. On the rotor, there are many slots. Okay, many slots, and I think it has 10 slots โอเคมี10 ร่องบากโอเคครับ10 ร่องบากไม่ใช่บาทนะครับบากกอไก่นะครับร่องบากปุ่มลงไปนะครับแล้วเขาก็ฝังเส้นลวดลงไปนะครับแต่ว่าก่อนจะฝังนะครับเส้นลวดต้องถูกหุ้มด้วยน้ำยาฉนวนก่อนนะแล้วน้ำยาฉนวนก็ต้องแข็งติดทองแดงนั้นไปตลอดเลยนะเพื่อว่านะครับเพื่อคุณเอาเหล็กไปติดกับเหล็กแล้วมันจะเหลือหรอครับกระแสมันก็ต้องไหลใช่ไหมอิเล็กตรอนกระโดดข้ามแน่นอนพอเราหุ้มฉนวนปุ๊บกระแสที่ไหลในเส้นลวดครับจะไม่กระโดดไปตรงโรเตอร์ที่มันสร้างจากโลหะเหล็กนะครับเหล็กอ่อนอะไรพวกเนี้ยโอเคyeah we try to prevent the escape of the electron by using by submerging the conductor into the any kind of liquid insulator, and after that the insulator it will get the solid state. Okay, it will be solid. Well, yeah, we connect the brush to this pair. Okay, there are 5 pair. Okay, the first 1 and 1 prime denote the first pair. 2 and 2 prime denotes the second pair. 3 and 3 prime represent the third pair. 4 and 4 prime represent the fourth pair. 5 and 5 prime represent the fifth pair. Okay, there are 5 pair for the conductors along this road. Okay, มันเป็นทรงกระบอกนะครับที่เราดูด้านหน้านะครับโอเค this is the front cross sectional area okay of the rotor นะครับคุณมายืนอยู่ที่ตรงหน้าโรเตอร์อันนี้นะครับโอเคไหมอยู่ตรงหน้าโรเตอร์แล้วมองไปนะครับคุณจะเห็นภาพตัดด้านหน้านะครับซึ่งก็คือรูปนั้นนะ alright you see this is the front view of the rotor right and there are 5 pairs of the conductor and the brush is connected to the is made to touch the conductor like this okay in 180 degrees from each other in what else the source the direct current source okay because we are talking about the direct current motor so we have to use the direct current source all right and that's the whole thing anything else nothing นะผมไม่ได้ใส่แว่นนะครับถอดแว่นนะครับปวดตานิดนึงนะครับyeah it's connected to the first pair of conductor in okay they use the dot here it means the conductor is the conductor lets the current flow and the direction of the current flow is out of this plane okay and this conductor is connected to number 1 okay at the front right here and at this side you can see the cross side it means the current flow into the plane okay the plane of this lecture note of this slide and now let's make analysis of the induced force why they say the FB on the left is downward the FB induced force on the right is upward you know that at this point you get the current flowing out of the plane right this is vector L and of course the vector B is like this is vector B right and you curl your 4 fingers from vector L to vector B right and you get the downward force like this which is F left okay F left on the left side and ใครมีคนมาเปิดประตู oh no I have to move มีใครเซียนครับเขาจะยกอันนี้ไปอยู่ทางซ้ายได้ไงผมวาดไปแล้วนี่มันต้องอยู่ F left อยู่ทางซ้ายครับ okay this is B right my god B and L in this way in F in this direction right it is F L F on the left side of the rotor all right ลบขออนุญาตลบนะครับ okay that's what's going on the left side you get the downward force and that's why you get FB in this direction okay from L L to B right yeah L to B like this L to B okay just curve it and on the right side you have magnetic field. You have the current pointing in this way, right? This vector L, and vector B is right here. Okay, that's vector B. Here L to B, right? It's somehow like this. So you curl your 4 fingers from L to B, you get the induced force upward FR. All right, right here. Okay, L to B, you get that. And yeah, you get the pushing force on the left, you get the lifting force on the right. That's the pair of the force, right? The couple force, simply speaking, we say torque, right? So the rotor is gonna rotate anti-clockwise, okay, or counterclockwise like this. And when this one move, okay, the number 5 will stay here and 5 prime will stay here, and the whole process will happen, okay, because the split link just give you the same direction of the current. So this one is going to have current pointing out of the plane, and this one, when it reaches this position, it would have the current flowing into the plane, okay, with the X sign here. All right, and it just rotates the whole pair of in this rotor. And of course you have 10 slot, right? 10 wires on this rotor. You can see that the angle in each sector from 5 palm to 4 palm, or 1 to 2 or 2 to 3, any sector will have 360 divided 360 and degree divided by 10 is going to be 36 degree. Okay, it means the angle between them is going to be 36 degree only. All right, can you see? I write it quite tiny. Yeah, it's only 36 degree. And what else? Nothing wrong, right? Yeah, let's go further. It just rotate, and you may ask me what happened if the brush doesn't contact any conductor at all. Okay, for example, the sector between conductor 4 and conductor number 3. Well, before that, the rotor just rotate, okay, but the rotor doesn't have zero mass, okay, มันไม่ได้หนัก0 กิโลนะครับใช่ไหมทุกอย่างมันมีมวลหมดนะครับแกนโรเตอร์มันก็ต้องมี because it has mass, okay, the whole thing here, whether it includes the conductor, it includes the soft iron, which is the core of the rotor. Okay, everyone here has its own mass, so the whole piece here can still rotate because of the inertia. Okay, the inertia keeps the rotor turning, and that's the reason. เหลืออีกประมาณ30 นาทีนะครับใช่ไหม 11:50 30, right? 20 นาทีครับ now we arrive at the induced current and induced EMF. Let's consider the first stage when there is no movement. จบไปแล้วนะครับเดี๋ยวเพื่อนจะบอกว่าอาจารย์อธิบายภาษาไทยเราก็เรียนเรื่องมอเตอร์กระแสตรงกันไปนะครับโอเคไหมมอเตอร์กระแสตรงก็จะการจ่ายไฟก็จะใช้แบบวิธีซับซ้อนหน่อยนะครับเพราะว่ามันเป็นการแยกระหว่างขั้วบวกลบชัดเจนนะครับเราไม่ได้ควบคุมการบวกลบโดยใช้ไฟฟ้านะอันนี้มันควบคุมการติดต่อด้วยแบบกลนะครับโอเคไหมตัดแปะอย่างเงี้ยตัดต่อกระแสไหลทางกลครับเมื่อเลื่อนถึงต่อโอเคไหมเลื่อนถึงกันเสียดสีกันยอมให้มีกระแสไหล